Giant's Causeway Geology. Walking into the causeway, you will notice the first weathered zone. This zone represents the exposure and weathering just prior to the deposition of the causeway columnar basalts. This weathered zone was downwarped into a structural trough or syncline.
Or soil formation in some instances at this stratigraphic level within the ancient lava group, you get piezolytic soils towards the top, iron-rich piezolytic soils. And well, there's a lot of movement of various elements, removal of certain elements and concentration of others. So concentration of iron, concentration of aluminium, removal of things like quartz. And despite all of that weathering and alteration, you can still see the structure of at least two lava flows here.
When the flowing basalt reached the rim of the trough, it poured in on top of the weathered zone and was flowing down the trough and simultaneously filling the trough with hot molten magma. Once in place, the 1,000+ degree basalt magma began cooling. The commencement of cooling was from both the bottom cooler rocks and the top cooler atmosphere. With cooling comes shrinkage and a natural vertical fractures propagating from both the top and bottom cooling fronts. The heat is radiating out. The fractures follow from the outside in. Along with the vertical fractures comes horizontal fractures. Each division is a segment. After cooling and fracturing are complete, then erosion begins with fresh water migrating through the fractures and converting the segments to rounded stones with spherical rings, cores with weathering rinds or onion skins.
The hill. Most of these kind of vertical structures that you could see within this rock volume were cooling joints. And since then you've had fluids moving through the rock and kind of weathering it from the outside inwards, if you like, and then creating these rounded core stones.
This is an example of the basalt core stone with a large weathering rind or onion skin effect. The vast majority of the basalt has now eroded away, but leaving a nice hard, uneroded area, or causeway, at the bottom of the trough, the bottom of the syncline. It follows the axis out into the sea. Now, looking from the top, you can see the regular but unusual shape of the top of the columns. They are striving for a natural hexagonal shape, and they are typically dished or dome-topped. The columns strive for a hexagonal shape because they both fit together, and the perimeter is smallest compared to the area. It is more efficient. Finally, you will see a dome and dish pattern on the top of the exposed basalt columns. This is formed during cooling. If domed up, the cooling front is migrating down, cooling the edges first. If we can help with your real estate evaluations or flood risks, let us know.